Hello, welcome to my session, SQL Code Testing Pipeline. I am Paul Oyan. I'm a solutions architect for Micron Technology, and this session is being recorded, but I will be live answering questions in the chat. So if you have any questions, just let me know. And also at the end of the presentation, I'll stay around and you still have more questions. So let's start with the scenario. Let's say, suppose you are a database engineer for a large manufacturing company, and the organization must support SQL code for the last, 5 SQL Server versions. And in large organizations, it's typically you will have several versions. It's not possible to have, a large amount of servers on the latest version. So you need to test that the SQL code doesn't break after either a code deployment or a CU release. Microsoft releases CUs or cumulative updates every month or every 2 months or so. And then you would like to automate the test using Azure DevOps and Azure SQL VMs. One thing to note is that we are using Azure SQL VMs because with VMs, you can control which version do you want. As opposed with Azure SQL Database, you always get the version, the latest version, no matter what. So the agenda for today is we're going to start with the initial setup, and then we will demo the automated testing pipeline. And we will finish with a deep dive of each pipeline task. So let's start with our initial setup. So on Visual Studio, we're going to use Visual Studio Code. You can use a text editor, but Visual Studio Code has a lot of extensions and IntelliSense that really help authoring scripts. And then all the code that we're going to use is in Azure repo, a source control. Now we are following the infrastructure as code best practices. So we use the source control that comes with Azure DevOps. And we also are going to create a pipeline to create those 5 VMs, SQL 2012, 2014, 2016, 2017, and 2019. But before we create the VMs, we're going to set up some Azure resources. For example, the resource group, which is a container of all the resources that we're going to use, and also a key vault, which is going to store the secrets or passwords. We're going to set up a virtual network where all those 5 VMs are going to share. And we're going to create a network security group to allow access to those VMs from the internet. And we are going to use the app registration, which is the configuration that we need for service principal. So the service principal is the account that we're going to use for automation. So the pipeline will have what we call a service connection to the Azure resources, which is also called like a service endpoint. So we're going to configure that so we can automate the process without using your account. We're using a service principal account. And all the scripts are here in this GitHub public repository. So we can take a look in a moment. And one other thing that I forgot to mention is that these resources that we create in the initial setup, if you don't use it, you don't pay for it. But the VMs, if you don't use them, once we create the 5 VMs here, once we don't, while we don't use it, we still have to pay for it, unless, well, you can stop it, but we still need to pay for the storage, even though they're, offline. So without further ado, we are going to see the code. So if we go to the internet, we're going to see the GitHub repository. So all the scripts that you are going to see today are here. And then there are the requirements. So you need an Azure subscription. There's a free trial, or you have an existing subscription, you can use that one. And there is you need an Azure DevOps account. And Visual Studio Code that is free, also the Azure client and the Azure DevOps client. So all these links will tell you, how to install it in your PC. But then if you also want to run the examples in your PC, so you need the PowerShell 7 and the Pester, Azure, and SQL Server modules. So all those modules are already on DevOps, but if you want to run the examples on the PC, you will need those modules also. So once you get an Azure subscription, it will look like this, right? So you can see that you have all these elements there. And then let's see, you can do a refresh to see if I'm connected. So yeah, I am connected. And then the Azure DevOps, once you install it, you install an account. It's also a free account. When it's empty the first time, it will ask you for a project name. So you can create the project also through the portal, doing all this graphical user interface or command line. That's we're going to use next. Visual Studio Code, I already have it installed in my PC too. So Visual Studio Code will look like this when it loads. So to start creating the objects, we're going to use Visual Studio Code, and we need to create a file. You do a new file, and then go back to the Git repository, which is over here. So there is one file called add demo resources, which is going to create the resources that we need. And there's another file called remove demo resources. So if you wish to do a cleanup, you run the commands that are there. But right now we're going to add the resources. So we just copy paste, or you can download the file. But I'm just going to do copy paste. It's not too long. So Control C, and then paste it on Visual Studio Code. So right now you'll see that it's all white characters, but once we save it as a PowerShell script, it will color code it. So let's do save as, and it will ask me for the name, and we can save it as demo resources PS1, which is the PowerShell extension. And once we save it, it will color code it. The comments are green, the commands are blue, or so on. And then it will also start the PowerShell integrated console. And then on the right lower corner, you will see 7.0 is here. So that's the version of PowerShell. So I'm using 7.03. So we are going to start creating the resources. So first we need to connect to the Azure cloud. You just run the Azure client command, which is AC login. So you just run it with F8. So we'll go to the internet and try to log in with your account. In this case, this is my account. So it'll take a few minutes until it logs in. Okay, once you are logged in, you need to provide your subscription name, which is here. And then you need to provide your subscription ID, the tenant ID, the location. So though I'm close to West US2, but you're close to another one, you can choose another one. The name of the resource group, the virtual network name, the network security group name, the rule name, the vault name, the service principal name, and the project name. And after that, we're going to use the AC group create command to create a resource group. Then we are going to create the virtual network with this command. Next, the network security group. And then we're going to create a rule to allow access to the SQL servers from the internet. And next, we're going to we're going to associate the network security group to the default subnet with this command. And then we're going to create a service principal, which is going to be the account used to connect to the Azure resources. Then we'll create a key vault, as I mentioned on the PowerPoint, and we'll add the secrets, which is the service principal password and the admin password for the SQL VM. And then I'm going to grant access to the key vault to the service principal with this command. So we can run all these commands all at once, the commands I highlighted, and it will take a few minutes to run. Okay, so now we completed. So we're going to run the next line. So the next command is to log into the DevOps account. So we can run this command from the client. And it will ask me for a token, which is the personal access token. So how you get the token is from here. You go back to the projects. And then on the upper right corner, there's an icon that says user settings. Then do personal access token. And I already have one, but I can click on regenerate to give me a new one. And I can copy to the clipboard. And going back to my Visual Studio Code. And I'll paste it here. And then do enter. And that's it. So I'm now logging to DevOps. Now I need to set up the project name, which is this. So it'll take a few seconds until it creates a project. So now I create a project. So now we need the service principal that we created earlier. We need a password. So I think it's still in memory. So that's the password. So far I haven't found a way to just pass as a variable. So when we create a service endpoint, which is the service principal account that is going to be used by the pipeline to log in to the Azure resources, you need to pass it on the command prompt. So if I run this, it will ask me for the key, which I already printed here. So I only need to copy and paste. And I need to do it one more time. Okay. And then I need to grant access to the pipeline to use the service endpoint. So I run it. Okay, so the next command that we're going to run is to import. So the public repository on GitHub, I'm going to import it to the private repository on Azure DevOps. So I just run this command, and it will copy all the code that is in the public GitHub to Azure DevOps. I'll take a few seconds. And then I need to create a pipeline also with this command. And that's it. So if we go back to Azure DevOps, for example, so remember there was no project, but now you will see a project there, which is this one. And if you go to the repo, you will see the same code that was on GitHub now is here because I imported. So the pipeline is created. And what else did we create? Oh yeah, the service connection is in the project settings. You go to the lower left corner, it says project settings. You click on it and it says service connections. So you click on service connections and this is the name of the endpoint that has the service principal to connect to the Azure Resource Manager. So in that way you can create the VMs automatically. And if we go to Azure Portal, if we do another refresh, we are going to see a demo resource group. Not there yet. Maybe you're here. Resources. Okay, this here, demo resource group. And remember, we had to create 3 resources near the demo NSG, which is the network security group, the virtual network, and the key vault. Now the service principal is under app registrations. So we click here. So we should see one that is called a SQL code testing demo. So that's the one that we're using to connect to Azure Resource Manager. So we're going back to our PowerPoint, which is here. So we already created all these components and resources. So now we are ready to run the pipeline. And the automated testing pipeline, the scenario was, every time you make a change in code, or if there is a CU release that you want to trigger this automated testing. So in this case, we are going to do a change in code. So the first thing is to change the source code in Visual Studio Code. Then we're going to commit a change and push it to the Azure repo. And then that will trigger the build, which is executing the tasks in the pipeline. And there are 5 tasks. So the first one is to create a VMs, which are all these 5 VMs, one for each SQL Server version, 2012 all the way to 2019. And the next thing is going to install the SQL code. Then it's going to test it using PowerShell tester framework. And then push the test results. So there is a graphical user interface for reporting on DevOps that are going to see. And then we are going to uninstall the VMs because, as I mentioned before, the only way to stop billing is by uninstall it. You can stop it, but you have to still pay for storage, but you uninstall it. You don't pay for anything if you're not using it. And since this is an automated process, you can easily install and uninstall. It takes about 10, 15 minutes. So we're going to check how to change the source code. So let's go back to Visual Studio Code, and I want to, I don't know, save this file and close the editor. So now we're going to clone the source code from DevOps repository, which is this one. So here on the right upper corner, there's a button that says clone. So we want to clone the code to your PC. So you click on it. So you are using Git commands. So there, the URL to do it. But since we are using VS Code, so we are going to clone in VS Code. So we click on it and you do allow. And then you want to put it, the repository in that location. Yes, sure. And now it's cloning the repository and it said you would like to open it. Yes, open it. So now I have the exact same code that is on DevOps on the cloud now in my PC. So I want to make a change on the code. So there's a new business requirement in one store procedure, for example, the insert demo table. So currently what it's doing is just inserting a row, and pass this parameter as a name. And, pretty simple for the demo. But now there is a new requirement that I need to pass a comma delimited list. And then you have to, parse each element of the list. And then, I do some research and I find out that there is a function that can do that for me. So I don't have to write too much code. So I'm going to uncomment it. And it's the string split function. So I get all excited and say, oh, that's all I have to do. So I'll comment my all change. And then I'm going to save it. And then once in save, source control will tell you, hey, you have one change to commit. And if you click on it, it will tell you what you changed it. In this case, I commented the previous command and commented the other one. So, but one other thing that we need to do, and I'll show it later, is so right now I don't want to uninstall the VMs because I'm demoing it. So I'm gonna run 2 or 3 demos. So I don't want to uninstall it and install it again to save time. So I'm just going to comment this part, and then I'm going to save it. So yeah, so now there are 2 files that need to be committed. So I'm going to put a comment, and I put demo, and I'll commit it. And then I'm going to push the change. So I push the change. So if I go back to DevOps, over here on the repo. So remember, I changed one script, which is the procedure, and it said update just now, and yes, so that's the change. And remember the scenario, so once I make the change, I want to automatically trigger the test on the 5 different versions to see if this store procedure remains compatible with all those 5 versions. So if we look at the pipeline, we see that it started already automatically. And if we go to see the details, to see what it's doing. So currently it's creating the VMs. So remember that there are 5 tasks that this pipeline is going to do. It's going to install the SQL VMs, then install the SQL code, then test the code, and push the test results, and at the end, it will uninstall it. So right now it's running, so it takes about 10 minutes. But while it's running, we can see what it's doing. So remember that we have a service endpoint, with a service principal, which is connecting to the Azure Resource Manager from DevOps. So if we look at our resource group, which is the demo resource group. All right, so remember that we only have 3 resources initially here. Now we have more because now it's creating everything that is needed. It's creating the storage account, the IP addresses, the NIC. And we can see that we are doing it through the Azure Resource Management template, because when we click on deployments here on the left, it will show that we are using this template that we're going to see later. But just to show you what it's doing right now. So it's creating the VMs. And as you can see, right now it's creating the virtual machines. And there are, so the ones that have this symbol that is running. So there are 5 that are being created in parallel. So one of the advantage of doing templates is that you can create all the resources in parallel. And in this case, we are creating it on sets of 5. And I'm going to explain that later. But currently, there are 5 VMs created right now. And it already created the IP addresses, the storage accounts, and the NICs. So we go back to Azure DevOps. So it's still running for a couple of minutes. So we can come back when you finish. Okay, now the pipeline finished. So installing the VMs took about 11 minutes, 5 VMs, and this is the output. It has the SQL Server version, the version on Azure, which is not the same version as the SQL Server version. So on Azure, the version is the date that the image was last refreshed. So this is the offering and the name, right? And all the rest are similar output. So there are 5 VMs, 2012, 2014, 2016, 17, and 19. So after you finish to create a VMs, you're going to install the SQL code, and then it's going to test it using Pester. And right now on the text, we already see that 2 tests failed. So the string split, it said invalid object name string splits on 2012. That function doesn't exist, and on 2014, that function that doesn't exist. So now that after we made a change, we tested, and we find out that string split is not backward compatible to SQL 2012 and 2014. And as I mentioned too earlier, so there is a graphical way to see the results, which is using this task, which is called publish the results. And if we go to that tab, so it's called test, and we click on it, so we run 20 tests and 2 fail. And if we want to see which ones fail, it will tell you similar error, right? So invalid object name, string split on 2012, and on 2014, similar message. So now we know that the change that we made is not compatible with the 5 versions that the scenario was asking. So now we need to make a change in our stored procedure to make it compatible. So we go back to Visual Studio, and you remember the stored procedure was insert demo table. So change 1 doesn't work on all 5 versions. So we're going to comment the line. We're going to use change to, which have an if statement. So if the version is greater than 11, which is 2014 and above, so if it's greater than 2014, excuse me, so then it will use a string split function. And if it's not, so if it's 2012 or 2014, it's going to use a custom function, which is over here. It's only using T-SQL commands to parse the comma from the list instead of using the the native function that is only available on 2016 and above. So once I make the change, right? So I'm going to save it. Now Visual Studio Code will tell me, hey, I need to commit this change. One thing I forgot to mention right now, so here on the lower left corner, it tells me I'm in master, so that it has the master branch. If I click on it, I can create different branches, depending what's your strategy, and we can create pull requests and add approvers. But to keep the demo simple, I'm just making that change directly to the master branch. So here I'm going to commit. So I'm going to do demo 2. So I commit the change. Then I'll push it to the repo on the cloud. And now if we go back to DevOps, so go to the repo. So I just made a change, just to verify if it's there. So go to procedures, and then I updated just now. And here you will see the change I made. So now the automated pipeline is going to start, testing the code that is compatible with all 5 versions. So we go to the pipelines. And there is a second one running. So the first one was demo, and the second one is demo 2. The first one failed because the string split function doesn't exist on 2012 and 2014. So now we made a change to make it compatible with all 5 versions, and now it's running the same code. So now it's going to create the VMs again, but remember that we commented the lines to uninstall it. So what it's going to do is, so another advantage to use templates. So the templates are idempotent. What it means is, if the resource already exists, it won't create it, and if it doesn't exist, it will create it. So the end result will be always what you're expecting, no matter what the starting point is. So in this case, it's going to take less time. So I think the previous run was close to 10 minutes, 11 minutes, I think. So this one will run less, but we'll wait until it finish. Okay, so now the pipeline finished, and this time only took 3 minutes instead of 11 because they were created already. So they're just checking that everything is there. So again, that 2012 version, 14, 16, 17, 19 with their respective IP address and version. So now it's going to install the code again and test the code. But this time there is no errors. So all the tests pass, and the publish test results is going to publish success. So if we go back to our pipeline on the test tab, so all 20 tests pass, 100% pass. So you get a trophy. So we can see that there is no failures. And if you want to see which test pass, you can click on here, and you'll see all the tests. I'm just doing a simple test that it doesn't return an error is one test, or the object exists is another test on each one. Now we're going to deep dive of the test I'm doing. But the main takeaway is that you can automate testing, and that you should test, every time you make a change. You can, do unit testing. So this is, unit test framework, and make sure that your code doesn't break on different versions of SQL Server. Um, so we're going to back to our PowerPoint. So now that we have demoed the pipeline, we're going to, deep dive each component. What are, the code behind installing the VMs, installing the SQL code, testing the code, and, uninstalling the VMs. To do that, so now we're going to run the code on Visual Studio Code. So that's the same things that we're running on the pipeline on the cloud. Now you can run it from your PC. So we talk about the pipeline. So the pipeline is this file called Azure Pipelines, and it's in a YAML format. And on the scenario said that we want the pipeline to be triggered, the build need to be triggered when you merge to the master branch. So that's this command here, the trigger master. But also you can schedule it to run, weekly, for example, every Saturday, or to run it, every time the CU, cumulative update is released. So before you apply the CU to production, you can test your code and see if it's going to be if there are any breaking changes in your code after applying the CU. So if your test is succeeds, then you can apply the CU to production. So then it will trigger jobs. In this case, I only have one job, but you can have multiple jobs. And then there is a couple of parameters that are important. So the timeout in minutes is 60. Now I set that timeout because, as I mentioned, you get charged by the VMs, right? So if there is a problem and your VM is still running, you get charged. And this is automated, so I don't want to be babysitting it. So I put a timeout in minutes of 60, and the next one, which is the cancel timeout, is the time that I have to clean it up, right? So after 60 minutes, I have 30 more minutes to clean up the VMs, uninstall all the VMs, which is the the last task in the pipeline. I can show it here. So that's the reason that the condition set if we succeed or fail. So no matter what happened before this task, the last task would always uninstall the VM, and this is the script that is running. So, but let's go back here to see what else I have configured. So there is a pool. So all these jobs are run by a agent or a server, and there are different flavors. There are Windows, Linux, and different versions. So I choose this one. And then there is a variable that get passed between tasks, which is the image offer, which is like the array of servers. In this case, there are 5 elements in that array. So the first task is an Azure PowerShell task. There are 2 tasks in DevOps. One is PowerShell and the other one is Azure PowerShell. So Azure PowerShell, what it's doing is just loading automatically all the Azure modules for you. So you don't have to do it, and you can connect to Azure directly. Then you provide name, and the Azure subscription is the name of the service connection that we created when we did the initial setup, and that service connection will use the service principal to connect to the Azure Resource Manager. So the script name is install SQL VM. So we're gonna take a look of what it's doing, which is this one. So it's going to initialize some variables, the name of the resource group and the name of the template that we're going to use to create the VMs and so on. So we are going to initialize it, and here I'm going to use the key vault to get the password of the VM admin account. So I'll just get that, and if I want to see the contents, you can also look at it, and it's there. So I'm just creating a credential. And then I'm going to list the 5 latest versions. So if I run this commandlet, which is get VM image offer, you will get several versions, like 2019 on different flavors of Linux and Windows. So which this set of commands are going to filter the ones that I want, which are the last 5 Windows versions of SQL Server. So now I finished, so I can look at the list. So, and you can see, 2019, 17, 16, 14, and 12, all in Windows. And I need to convert that variable into an array of hash tables, because that's the way I'm going to pass this parameter between tasks. And the way you do it is just iterate through it and change the format. So now if I look at inside the variable images, so now are in this format, key value pairs. It's an array of key value pairs. And it has the name of the SQL VM. So each one is named SQL W2 test 0, 0 to 4. There are 5. So once I get the image variable, I'm going to pass it to the template, and this commandlet is going to deploy the template. So I'm passing the parameters. I'm passing the image, which is an array of 5 VMs, and the accounts from the vault, the password from the vault, and the template, which is this one. So then automatically, Visual Studio Code will load the extension to parse this template. So it makes easy to make changes. So for example, it already knows that there is a parameter template. So if I can click on it, so the parameter templates are the values that I want to pass to the parameters. And it's already highlighting this one, and the IntelliSense will tell you, hey, you don't have values for the admin password and the SQL authentication password. And the reason is because I'm passing those values that I got from the vault. And that is on install SQL VM. So these are from the vault. So going back to the template, you will see there are 5 main sections. So there are parameters, variables, resources, and outputs, and the schema over here. So the parameters are the values that you can provide here or through a parameter file. That's what I have, and then I have a couple of variables here that I use. But the main part are the resources. So here you tell the resource manager which resources do you need. In this case are network interfaces, public IP addresses, storage accounts, virtual machines, and SQL virtual machines. But if you scroll down a little bit, there is a particular command. It's called copy. So you have to create 5 resources each, and the way you tell the template that is with this copy command. So remember that images is the variable that has the 5. It's an array of 5 VMs. So the reason I said length is 5. So it knows each resource had to be created 5 times. For example, the first one, right? So I am providing the name, and the name is the name of the VM, for example, this one, plus suffix, which is the nick. So it knows it had to create, in this way, 5 network interfaces. And in the right dependency order. So it's also going to create 5 public IP addresses and 5 storage accounts and 5 virtual machines and 5 SQL virtual machines. And how do you start? Do you create a template from scratch? You can, but the easy way is to go back to the portal, go to the Azure portal, and let's look at a resource. So you can do it in different ways, but the easy way is create a resource that you're interested, or choose one that's already created, and then on the left pane you will see an automation section, and you say export template, and then it will show you the template. So for each resource, so you just copy paste this template on Visual Studio Code and just replace the things that you want, the parameters, and that's the easiest way to get the template. So going back to our script here, so after I create the template, I'm going to get the IP address because I don't have a DNS service running, so I need the IP address to connect. And with that, and the reason I need to get the IP address is because the output on the template doesn't support the copy command, right? So output here, I just put the dummy value, but you cannot use copy on output. So it cannot tell me the IP address as an output. So I had to get it using PowerShell commands. So if I'm going back to here, so you can get the network interface and then the IP address with these commands. And while I'm looping through each VM, I'm going to connect also and get the SQL version that you saw on the pipeline. So I'm going to highlight all this and run it. And it will take a couple of minutes or so to return. So while it's running, I'm going to explain the next task. So the next command is going to convert the variable into a JSON format, because I'm going to pass that as a variable to the next task. And to do that in DevOps, you use this special syntax here to pass the variable. And if I run it, you will see it. So it's the same array of 5 VMs, but now it's in JSON format in this way. So this one will go to, I'll pass this variable to the next task. So if I go back to my pipeline that is here, so I generated that. So that's the image offer parameter. So now I'm going to explain this install SQL code script, which is this one. So if you go back to the end over here, so we are going to initialize these variables too. And I made each task to be as independent as possible, so you can replace the task with another task if you need to. So that's the reason I'm getting the credentials from the vault again. But now I'm going to create a hash table which have the script names. And so I have a naming standard for the script. So I have the script folder, which has a database subfolder with the tsql command to create a database, and then the functions folder, the procedures folder, and the tables folder. So all these ones, I'm just loading it to a variable so I can easily access them. So I just load it, and if I want to see what it contains the same file names that are over here. And then I'm going to pass it to this function, invoke script grouping. With all it does is just executing those scripts in order, databases first, then tables, then triggers, then functions, then procedures. And the invoke script object, all it does is just invoke SQL command, which is this one. So I'm going to invoke the script, and there is a try catch. So if there's an error or if the object already exists, it will display this message. So I can run it interactively too. So I can minimize this and load the functions into memory. So now they are there. So I can execute it interactively from here, and it should run. So yeah, because I didn't delete the VMs because I knew I was going to do this demo, so I'll have to recreate the VMs again. So it said that there is already an object name created. So, but this is the IP address of the first server, the IP address of the second server, and so on. So now I already install all the SQL objects that I needed. So now the next task on the pipeline is testing the SQL code. And this one is this file. And all it's doing is invoking pester, which is the command to invoke the test. And this is the file. And it will pass the output to the next task on an XML format. So let's take a look at the SQL code main to see what it does. And it's this one over here. So first thing is going to .NET, or it's going to .source, a function, which is the test SQL call function. So we will take a look at that one, and it's this one. And I'll just give you an overview, but if you want more details, I wrote a chapter on the PowerShell conference book, and you can get the book from there if you want more details, but I'll show some examples here. So it's going to run the pester framework, and on the pester framework, in simple terms, it has to have a describe block, which is this. So it's just grouping tests. So it's like a group of tests, and I pass the version string and the object name and the test type. So it's going to name that describe block using those variables. And then it's a collection of it blocks. So the it are the test itself. So it has to run something and compare the actual result with the expected result. And that is with what they call an assertion. In this case, it should not be. For example, in this particular case, what I'm doing is I'm checking if the object exists. So I'm just running this SQL command to find the object ID. And if it's blank, that means blank or null, that means the object doesn't exist. So that's the reason that the result, which is the object ID, I'm doing this comparison, right? So it should not be blank. And if it is, this test won't pass, right? So this is the object exists test. If you have tables, you can also test for tables. It's going to run sp help object name. And On Pester, you can compare arrays, so you can do an assertion with the arrays, the actual result with the expected result. And then if the test doesn't pass, it will show that the test didn't pass. And similar for index definition, you're going to run SP help index and compare the actual with the expected result. And then if we want to compare the row values, also we can do that. There is a item array property that will show you all the values. Or if you just want the first row value, you want to test column names, or you want to test number of rows, return it, or the procedure parameters. You do SP help and it will give you the parameters of store procedure. And what else? And if there is an error, so if there's an error, it will throw an error, and if not, it won't. So the way I do it is with this should not throw assertion. But that's the function that you can call from any script just by doing the dot source. So here I can call this function from any other script that I write and do the test. So the other thing that we're going to do is to see what the test cases are. So the test cases are this file, and I'm just testing two store procedures. So the reason the test type is proc, and a delete procedure and an insert procedure, and I'm only doing 2 of the 9 tests. I'm just testing if the object exists and the store procedure doesn't return an error when it's executed. So back to my main function. So I just need to run it over here. So now we loaded the test, and the SQL code test scenarios are here, right? So now they are in a key value pair format. And then again, I need to get the credentials from the vault to log in so I can run this. And then there is a loop. So for each procedure and for each image, I'm going to run the test SQL code. So I parameterize all this pester testing. So all you have to do is run this, and it will run all the pester tests. So by default, it doesn't show output, but if you want to show output, you go to the SQL code here, and then you do output detail, and you will see all the tests that it's doing. So remember that describe is a group of tests or it blocks, and each test has a name. So I'm just setting that it's not returning an error and the object exists. Only 2 tests, because there are 5 VMs. 5 multiplied by 2. There are 10 tests here. Oh, excuse me, 20 tests. Because I have 5 VMs here. And then I'm going to run the next task, which is this one over here, which is so once I get the output of this, I'm going to pass it to the report on DevOps, the ones that you saw there that has the trophy if you don't have any error. And the last task is to uninstall the VMs. So I'm going to take a quick look. I know it's a lot of code, so a lot to digest with this one. Uninstall VM. So remember I commented it. So you want to uncomment it, this one. Okay, so here you will have this command to delete each resource. So I'm going to get the resource by the tag. So each resource that I created through the template has a tag name. So you are sharing the resource group in your organization. You don't want to delete the entire resource group. You can delete each resource on the group, because you might be sharing the resource group with other projects. So in that way, I'm deleting just the resources that I created with this tag value. And then I have an error checking. Sometimes it times out, so I try 3 times just in case it times out. And we can go to the portal. And for example, on this VM that I have here, so all they have this tag, the SQL code test. And if you click on it, it will tell you all the resources that have the same tag. So you can delete by tag value. Go back to the Visual Studio Code, and then yeah, so you can run this and it will delete it. And that was the last task of the pipeline. And that's I think the end of the presentation. So go back to my PowerPoint, and yeah, so we already did the deep dive. It's a lot of code, but it's automated, so you can test any changes either when you change it manually or when there is a change of CU cumulative update. You can run this test and before you deploy the change to production to make sure that the code doesn't break. And so that's the the main takeaway is that you can automate the test. And let's see, the next slide is special thanks to Microsoft for supporting. Data platform geeks and SQL Server geeks and community initiatives. And just thank you for attending. And there are 3 ways to win prizes. Post your selfie, give feedback, and visit sponsors and exhibitors. And that's all for now. And I'll stick around if you haven't had a chance to ask me a question live through the chat. I'll still be available, so you can ask more questions. Thank you.